This is 4.1 translations. So we are talking first about transformations, and transformations are any operation that maps an original figure called the pre-image onto a new figure called the image. A transformation can change the size, orientation, or location of a figure. All right. Notice in our example here of our first transformation, we have 4 points, A, B, C, and D. And when we move this in a figure, I now actually have some apostrophes on them. And that actually stands for prime. So the pre-image will be the regular letters. The image will be our prime. So a translation is to vertically and horizontally move or translate a figure. So in symbolic form, we would write it as every point x comma y becomes x plus a comma y plus b, where a represents the horizontal translation and b represents the vertical translation. So a rigid transformation or a congruent transformation is a transformation that preserves length and angle measure. So that means the first picture and the final picture will be congruent to each other. The same way that segments can be congruent, the same way that angles can be congruent, the entire shapes are congruent. So in our first example here, we have triangle ABC, and we want to graph its image after the translation, x comma y turns into x minus 2, y plus 1. So that means on the graph, for every point, we're going to translate negative 2 horizontally, which means back 2, and plus 1 vertically, which means up 1. And that's how we would come up with our prime point. So there, a prime would be negative 1, 3. Oops. We can also do this algebraically. So 1 minus 2, right? The x value is 1, the x is minus 2, so 1 minus 2 is negative 1. The y value is 2, we're doing 2 plus 1 is 3. So let's try the next two algebraically. So we're going to do positive 1 minus 2 is negative 1. Positive 5 plus 1 is 6. And that would put our point at negative 1, 6. And then C prime, so 6 minus 2 is 4. 2 plus 1 is 3. So the point 4, 3 would be C prime. And then we do our best to draw the new shape. It's not going to be perfect, and that's okay. All right, so that was our first translation to the left and 1 up, because it was x minus 2 and y plus 1. Let's try another one. We have quadrilateral ABCD. We want to graph it and its image and its translation x plus 3, y minus 1. So plus 3 for negative 1 is 2, minus 1 from 2 is 1. Plus 3 to negative 1 is 2, minus 1 from 5 is 4. Plus 3 to 4 is 7, minus 1 from 6 is, sorry, got struck because that's not going to be, is 5. And then 4 plus 3 is 7, 2 minus 1 is 1. So we have the point 2, 1, 2, 4, 7, 5, and 7, 1. And that would be our transform figure. And C prime right there. So you're going to go ahead and try this one, pause, and when you're ready to check your answer, hit play. Okay, so we end up with A prime is 3, 1, B prime is 6, negative 4, and C prime is 8, negative 2.
So the next thing we're going to look at is determining what the translation was to get from one shape to another. So we know it's a translation because all the points are in the same orientation. It's moved, slid from one spot to another. I'm going to take one point and a matching prime point, right? I have to pick matching points, but I'm going to check moving to the right on my curve, then up or down second. So we start by going over 1, 2, 3, 4. So we went x plus 4. And then from there, we went up 1, 2, 3. So that's y plus 3. So this was x, y goes to x plus 4 and y plus 3. We are going to go ahead and try this one. Write the rule for the translation from PQRS to P prime, Q prime, R prime, S prime. Pause, and when you're done, play the second. Okay, so our rule would be x plus 1 and y minus 3 because it moves down. So now we're going to look at this strictly algebraically, and it says use the given translation to answer the following. What is the image of A if A is negative 1, 3? So we're looking for A prime, which means we're looking for the result after I've taken 5 away. So negative 1 minus 5 is negative 6. And if after I've added 3 to y, so 3 plus 3 is 6. But the second one asks what is the pre-image of B prime. So they're giving us the result after we've already done this, which means that x minus 5 gave us a result of 5, which means x was originally 10. And y plus 3 gave us 7, which means y was originally 4. So our pre-image point B would be 10, comma 4. And let's check that. If I were to transform point B, 10 minus 5 is 5, 4 plus 3 is 7. So that would have been our pre-image. So go ahead, give this one a try, pause, and when you're ready to see your answer, hit play. All right, so the image of A would be 8, negative 9, and the pre-image of B prime would have been B was negative 9, 10. When two or more transformations are combined to form a single transformation, the result is a composition of transformations. So we're going to have a whole section where we talk about compositions of transformations. But for today, we're going to talk about a composition of two translations. So in our example, we want to graph RS with these endpoints and its image after the composition. So the first thing we would do is I would perform the translation of x plus 5 and y minus 2. So that means r prime, negative 8 plus 5 is negative 3, 5 minus 2 is 3, and s prime, negative 6 plus 5 is negative 1, 8 minus 2 is 6. So that puts us at negative 3, 3, and negative 1, 6. And now we're going to do the second translation to the primes. So that means from these two now, I'm going to get something called double primes. R double prime and S double prime. So I'm going to do x minus 4, but now I'm going to do negative 3 minus 4. And y minus 2, which means 3 minus 2. All right, we're going to do negative 1 minus 4, which is negative 5. 6 minus 2 is 4. So that's going to put us at negative 7, 1, and negative 5,
4. The next problem is asking, what would the composition have been as a single translation? So how could I have gotten from RS to R double prime S double prime if I only wanted to move once? So we would look at this, and I'm looking at going from R to R double prime is to the right one and down 1, 2, 3, 4. And the same thing for S to S double prime. The right one, down 1, 2, 3, 4. So that tells me that my single transformation would be +1 and -4. Now let's look at this. +5 and -4 together, right? +5 minus 4 is a +1, and -2 minus 2 is a -4. So that's also how we can get our composition as a single translation. So that's actually it for translations, but I'm going to throw a little bit extra in here about horizontal and vertical lines, because we need to know how to graph them for the next lesson we're going to learn, which is reflections. So we have something called hoi vux, and this is a set of letters to help us remember how we look at horizontal lines and how we look at vertical lines. So that's what the H and the V stand for, horizontal and vertical, and the X and the Y represent what the equation would look like. We don't care right now about the O and the U. O actually stands for 0 for slope, and U actually stands for undefined slope. But for right now, we care that H is horizontal lines will be in the form y equals some number. And vertical lines will be in the form x equals some number. All right, but the V and the X for vertical and X, the H and the Y for horizontal and Y. So is the line X equals 4 horizontal or vertical? So if I wrote out point up, X is over here, it belongs to be for vertical. So when I want to graph the line X equals 4, I would move over to 4 on the x-axis, because that's where X is 4, but then I'm going to draw a vertical line. And that would be the line X equals 4. So is the line Y equals -3 horizontal or vertical? So again, in hoi vux, here's our Y, and it belongs to H for horizontal. So I'm going to go down to where -3 is on the y-axis, and then we're going to draw a horizontal line through that point. Right? And that is also graphing horizontal and vertical lines. That is the end of this lesson.